Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph vertical and horizontal linear inequalities. Now, the main important thing is when we're getting into these, a lot of students get confused because they remember how to graph when something's in slope-intercept form, especially when we have an equation. And inequalities just complicate things a little bit, but in reality, it's the exact same technique. We're just still identifying the y-intercept and the slope, except the inequality just tells us we're going to be shading, and then also looking if we're going to have a dash or a solid line as our boundary line. But when we have just x or a y, we need to go ahead and think about what exactly those represent. So the best example here, I'm going to actually start in the middle, is to forget about the inequality and just think of these as, think of these as just equations. Now remember, I could create a table, which actually I will here real quick. Okay, and if you're going to create a table of values, an x and a y table, well, here x, no matter what y equals, x always equals 1. So where does x equal 1? Right here. So it doesn't matter that's x equals 1 when y equals 0. You could have x still equals 1 when y equals 3. And what about like -2? It still equals there. Now remember, x equals 1 for whatever value of y. So it's just not going to be little points, but it's going to be a line. So therefore, you can think of that as a vertical. Whenever you have x is less than or greater than or equal to, it's always going to be a vertical line at that value for x. Now, since this is less than or equal to, we know that's going to be a solid line. Then we need to determine our shading. Okay? Now, the best way to go ahead and confirm that is to choose a test point that is not on the line. And the best one to do is 0, 0. However, for our inequality, we don't have a value for y. So guess what? We can't apply it. All we can do is apply the value for x. So we just determine is 0 less than or equal to 1. And that is true. So since that is true, we are going to shade all the points going to the left. Because if the test point's true, that means all the points to the left are going to be true. All right, so then we can now do another table. And now y always equals 6. For whatever value, 1, 2, 3, 4, 5, 6, y always equals 6. Okay? So it doesn't matter what x is. X could equal 1. X could equal -1. Right? It doesn't matter what value I pick. But remember, y is always equal to 6, no matter what value of x. It could be decimals, fractions, so forth. So therefore, that's going to produce a horizontal line. Then again, we can plug in our test point. And again, on the test point, we don't have a value for x, but we can plug in the value for y. And this one is 0 is less than or equal to 6. So that's going to be the values that are going down. And therefore, you can see that the feasible region is going to be where our two inequalities intersect, which is going to be right where those two inequalities cross. Right there, right? You can see they cross, they intersect. So that would be our feasible region. So the other thing to remember is since you have this solve for y or for x values are less, you can just think of what are the x values that are less than x? Well, that's going to be everything to the left. What is going to be everything that's less than y? Well, that's going to be values that are below that. So you could use test points like I did, or you could also just look at the inequalities and help you with the shading. So in this case, I have x is greater than -2 and x is less than 4. So I know that's going to be two vertical lines, and they're also going to be dashed. So I'll go to -2, and I'll do a vertical line. And then I'll go to 4, and I'll do another vertical line. OK, so for x is greater than -2, that means all the values that are greater than -2. Well, that's going to be values going to the right. And x is less than 4, that's going to be all values going to the left. Now, you can see that these actually go in opposite directions. But you can see where it's true for both of them is going to be this unbounded region in between. OK? So that's going to be our solution set where our two inequalities intersect. In this example, we now are going to have two horizontal lines. So at y is greater than 5, I'm going to go up to 5. 1, 2, 3, 4, 5. It's greater than or equal to, so it's going to be a solid line. Then I'm going to go to y is less than or equal to -2. So I'll go down to -2. And I'll do another solid line. Now, this is y is greater than 5. So all the values that are greater are going to be above. And y is less than is going to be below. So you can see this one, they do not intersect. So we do not have a feasible region in this example. So there you go, ladies and gentlemen. That is how you graph a system of two vertical and linear inequalities. Thanks. How you doing, sir?